Hello everyone, I'm Lola Shane Gambo from Bachelor of Science in Accountancy. So today, our topic that we're going to discuss is about symmetry. For us to better understand what is symmetry, let's have an example. So for example, a butterfly. Okay, that's a butterfly. So when you draw a line in the center, you will notice that the left side of the wings looks exactly similar to the right side. And another one is symmetry. It is when two sides look similar to one another. Next, mathematically, symmetry patterns can be described using group theory, where different symmetries are grouped based on their operation. So, what is group theory? It is when symmetry can be viewed on different set of operation, and each object or a one shape can be transformed while maintaining its structure or pattern. Okay, for example, a star. When you try to flip or move it to the left side, it still looks the same. It remains unchanged. Symmetry can also be seen in nature. Symmetry is intrinsic to many living organisms, from flowers and leaves to animal markings. It can serve purposes like camouflage, attraction, or structural stability. So when you look around your surroundings, symmetry can be seen everywhere. Another one, in architecture and design, buildings, bridges, and monuments frequently use symmetry to convey balance, elegance, and strength. So when a building or bridges doesn't have a symmetrical patterns or figures, it will likely not to function. Next, art and culture. Symmetry is a key principle in many art forms, particularly in Islamic art, where intricate geometric patterns emphasize balance. So there are a few main types of symmetry. First, reflectional or mirror symmetry. So this one is the most common type of symmetry. Reflectional symmetry it is when the other half of an object or figure mirrors the other side. Just like what I've exampled earlier, a butterfly. The other half of its wing looks exactly similar to the other half. Next is rotational symmetry. So when we say rotational symmetry, it is when an object or figure, when you rotate it in a certain angle on a central point, it looks exactly the same. So the third one is translational symmetry. It is when a shape or pattern repeats itself on a straight line. Lastly, radial symmetry. So radial symmetry, it is when an object or a figure rotates outward from its central point. So you can imagine a flower, specifically a sunflower. So its petal is arranged outward on its central point. So this is one of the examples of radial symmetry. So here are some common examples of symmetry that we can see in nature. First example is a starfish. So as you notice, a starfish has an arm arranged around its central point. So this is the central point. This is its arm around. Okay, can you guess what type of symmetry is this? You're right. This is rotational symmetry. So because when you rotate it, usually in 72 degrees, a starfish looks exactly the same. This is a rotational symmetry because even though how many times you turn it, it still looks identical each time. Next is spider web. A spider web has threads radiating out from the central point, like a spoke of a wheel. And it has a ring arranged around its central point. And from the word itself, radiates, it is definitely radial symmetry. It is radial symmetry because no matter how you look at it in different angle, when you look at it in the upward angle or the downward angle, it still looks the same. Next is peacock feather. So a peacock feather has a central line creating a patterns on either side which mirrors each other. From the word itself, mirrors, it is definitely a reflectional symmetry. It is reflectional symmetry because as one side of the feather mirrors the other side. Okay, another example. Animal stripes or spots. An animal stripes or spots has a symmetry that can be divided in the center. And some of the animals, specifically zebra, you can draw a line on its center, and each side of its body shows a similar patterns or design. And this is classified as reflectional symmetry. Next, spiral shells. So as you notice, a shell has a central point which radiates on its outer shell. So from the word itself, radiates, it is radial symmetry, because a radial symmetry, even in different angle, no matter if you look at it this way or this way, it still looks similar. Next, a tree branch. So a tree branch is an example of fractal symmetry. So what is fractal symmetry? A fractal is a pattern that has a self-similarity. That means even if you look at it in its large size or on its smaller size, it still looks exactly the same. So this example is an example of fractal symmetry. So this example is what we commonly see in our house or in school or in our surroundings. First is wheels. So you can see this in the streets. So wheels has a spoke around its center point, which is this, and its spokes radiate outside on its wheel. And from the word itself, radiates, it is a radial symmetry. Next, a window. So a window. Next is window. So we commonly So second example is window. So window, yeah, we can see it everywhere, even in our own room. So a window, as you notice, it has a line on the center, creating a balanced structure on its both sides. So as you notice, this side has similar looks on the right side. So this simply shows that this figure is an example of reflectional symmetry, which is they mirror each other. So next is clock. So as you notice, a clock, especially a circular one, it has a round shape with its number arranged around its central point. So this example is a type of radial symmetry, because when you rotate it on its right side or on the left side, it still looks the same. The numbers and its shape still look similar. Okay, another example that we can see in the culture of the Philippines. One of the example is tinala. So tinala is a woven fabric usually seen in the Tibuli people located in Mindanao. So as you can see, its pattern, which is diamond. When you draw a diamond on the center, it has a so when you draw a diamond on the center, it has a similar shape or patterns on both sides. So this creates a mirror images, which is one of the example of reflectional symmetry. Another one is the parol or the Christmas lantern in the Philippines. So as what I example earlier, just like the star, okay, it is usually a star shape. So it has a center point in the center, and it radiates pattern, or it is arranged outwards, which creates a radial symmetry. Lastly, the Manunggo jar. It is the most known burial jar in the Neolithic period. So as you can see, it has a boat on the upper side, which also has two people sitting in it. So this creates a mirrored image in which, even though when you rotate it or when you move it on the other side, this figure looks the same. So this creates a reflectional symmetry. Okay, our last example is this. So laptop, we commonly use it nowadays, especially especially for students. So a laptop, when closed, the top and bottom of its shape looks exactly similar, or has a similar shape. So this creates a bilateral symmetry. So when we say bilateral symmetry, from the word itself, bi means two. Its two sides has a mirror images. Okay, next is the human face, our face. So when you draw a line on center, each side has a similar images. So when you look at yourself in the mirror, you will notice that your ears, eyes, and nose looks exactly the same in the left side. Next is diamond. So diamond has different types, but the most commonly shape that we see is the round brilliant cap. So it has a central point which rotates outside of its corner. So this shows that this is a radial symmetry, because no matter how you flip this diamond or you turn it on the left side, it still looks identical. Okay, so symmetry is important or has a crucial role in our daily life, because imagine if the wheel of the bicycle or a bus has no symmetrical patterns, it will likely fail to function. Many everyday items like smartphones, laptops, or kitchen appliances incorporate symmetry to improve its functionality and usability. Symmetry is often associated with beauty and attractiveness, just like what we see in nature, our human face, or even the leaves that we see outside our surroundings. Okay, so that ends our discussion. Here are some references that I use for my discussion, and if you want to study more or dig deeper about the symmetry, you can use these references to study. That's all. Thank you.